And let's go on to this new topic. So there's a file to download. Let's get that file downloaded and open. The topic that we're covering today is arrays. It's like a fundamental structure in like lots of different programming languages implement this idea. So I know some of you have some programming experience, so help me understand where you are. How many of you here already can use arrays? I know I can. Every time I get a paycheck, I look at it and say, boy, I sure can use arrays. There's not that many jokes here, folks. You got to take what you can get. So I'm going to share with you a little bit of a story because this is mostly to remind me that when I first encountered what an array was, it was a difficult concept for me to grasp. So it turns out my father was, like, for most of his career, he was a general contractor. And then my Uncle Jim, who, and we were raised in Southern California, but we would often visit my Uncle Jim, who lived in Salt Lake City during the summer. And we were there visiting one summer. It was about 1979, so I was, maybe not quite even a teenager yet. And I'm sleeping in a basement room. There's a large house in the Avenues, and I'm sleeping in the basement room. And my father, who was not a prankster at all, like, came into my room about 5 o'clock in the morning, and he said, "Son, the house is on fire, and the fire department has asked us to evacuate." I mean, that was the way he put it. The fire department has asked us to evacuate the house. Like, it's not enough that the house is on fire, we should get out. No, the fire department has asked us to evacuate. I knew that he was serious. He would not make a joke like this. And, so I got up. I don't think I put shoes on. I think it's just like, you know what? I'm going out. And sure enough, like, there's fire trucks, the house is on fire. They're hosing, they're spraying, fire hoses onto the house. I think it's smoking now, but it's not, it's not in flames. And anyway, Uncle Jim hired my father to, like, remediate the fire damage to his house. And what had happened was the home was divided into like a main living house and then a couple of apartments, and someone had fallen asleep smoking in the upper stairs, the upper apartment. And so my father then did the fire remediation on my uncle's house. It took a year or so. And as part of the payment, my uncle, who was a brilliant programmer, taught my father to program. And it was like, I'm paying you, some money for this, and I'm going to teach you how to program computers. It's the late 1970s. Computers are starting to be kind of a big deal. So my dad learned how to be a programmer. The truth is, he was never a very good programmer. He went and actually worked. He programmed in Silicon Valley for 4 or 5 years. Then he went back to building, which is kind of where his heart was. But it happened to be these formative years when I was kind of young but old enough to kind of get started. And so here's my father, who was not a very good programmer, and, as it turns out, was not a very good teacher, trying to teach me one day about this idea that I'm going to teach you today. And I still remember it. He said, "All right, I'm going to teach you about arrays, son. Sit down, son. I'm going to learn you something. I'm going to teach you about arrays." And I said, "Great, Dad. I want to learn about arrays." He said, "Arrays are like pigeonholes." And I don't know what part of my life experience he thought would be meaningful when he talks about a pigeon. To this day, I don't even know what a pigeonhole is. Pigeonhole. Do we have any images of what a pigeonhole is? I don't want a video. I want an image. Oh, yeah. I can see why that's an array. But I had never seen one of these. It was like pigeonholes. I'm like, okay. And I'm imagining something like, what's that bird that like makes a nest out of mud under bridges? Is that a swallow that does that? Gutter snipe. Anyway, I'm imagining something very, very different from this. And so I'm like totally not understanding what he's trying to explain to me. And he says, "Okay, forget that." He says, "Arrays are like post office boxes." Now, we look for like a post office box. And look at an image of, you look at post office box. I look at that now and I go, oh, I can see why that could be a good metaphor for an array. But like, I grew up in rural San Diego County. Like, most of my neighbors like had horse property. I don't think we had horse rights on our home, but most of my neighbors had horse property. I remember when we got our first stoplight. This was like rural. So R-U-R-A. I don't think I'd ever been to a post office in my life when he's trying to explain this to me. And what's a rural San Diego post office box? I must have Googled that before. Yeah, this is what post office boxes think. This is, in fact, there's got to be a better one than this. Those are even like more organized than the post office boxes that that I was raised with. Anyway, something like, yeah, this is better. Something like this. So he's talking about post office boxes, and I'm thinking about this. And I'm just not getting it. After what seemed like hours and hours and hours, but was probably not more than an hour or an hour and a half, I'm in tears. You know, I think, I'm just a moron. I can't figure this out. My dad's in tears. He thinks my son's a moron. He can't figure this out. And we gave up. Like, went away that day not knowing what an array was. But you're in luck. As it turns out, I'm a pretty good programmer and I'm a pretty good teacher. So I'm gonna help you get this today. It's not going to be the experience that I had when we first started. So hopefully someone here has a connection to a worldwide network of information where they could search something. If you would, just give me an English language definition of the word array, A-R-R-A-Y. Just what does it mean in English? I'm not looking for like a computer science definition. Just look it up and raise your hand. Okay, go. What does it say? If it's the right one, I'll let you keep going. If it's not, I'll find someone else. Oh, that's perfect. Don't lose that because I'm going to have you say that several times today. Say it again. I'll read it one more time, nice and loud.
An impressive display or range of a particular type of thing.
An impressive display or range of a particular type of thing. So I might like look before me and I could say, in fact, does it make any sense for me to say, what a magnificent array I behold? Does that make sense? Like in the English language, does that make sense? What am I missing? What do I have to add to that to make it just, yeah, what an impressive array of students I behold. Do I see an array of students before my eyes? Say it again. An impressive, what is it?
An impressive display or range of a particular type of thing.
You are an impressive a range of a particular type of thing you're a student. I might say, oh, what an array of seats I see before. What an array of steps. An array, to be meaningful, has to be an array of something. Somehow, and it's the same what we're talking about today. Like an array in computer science is an array of something. And it does not make any sense in the English language to say, oh, it's an array. And yet that's what we call it. Like we shortcut it and we just call it an array. But what is an array of? If I was going to say, like when we're talking about using an array in VBA, it's an array of something. What is it an array of? Any guesses? We can hold integers in an array, but it is not an array of integers.
Is it an array of cells in the spreadsheet?
It's not an array of cells. I could look at the cells, and in the sense of the English language, I could say, what a beautiful array of cells. But it's not, when we say array, it's not an array of cells. An array of objects. Good guess. Not an array of objects. Yep, we'll take two more. Yeah, say it again. Oh, that's so close. It's an array of variables. So an array is an array of variables. Someone remind me what a variable is. Let's just open up Excel and VBA. Anyone, just give me an idea. Tell me something you know about, I don't have to give me the definition, just tell me something you know about a variable. What a variable is. A variable holds a value. So a variable is a location in memory with a nickname. So I don't have to think about it by its address. I'm going to do this. I'm going to come here in my code, and I'm just going to come in here and make a sub procedure. My caps lock on or off? Caps lock is off. Sub. I'm going to call this initialize, I-N-I-T-I-A-L-I-Z-E. And I'm going to come right in here, and I'm going to say dim hotel as string. And when I do this, I have made one variable. It is when this gets processed, the VBA interpreter is going to send a request to the operating system that says, hey, I'd like some memory. How much is it going to say? Oh, it's a string. So it's going to start off by saying, I want 4 bytes. Give me 4 bytes of memory. And the operating system is going to go, here's 4 bytes. It's all yours. And then it's going to go, great. I'm going to keep track of that location in memory with that name. So it is the name with the location in memory that is what a variable is. And so an array is, in VBA, an array is in VBA, no, just read your definition. I'm going to fill in the part you don't know.
An impressive display or range of a particular type of thing.
Variable. Yeah, and not a particular type of thing, a particular type of variable. An array is an impressive range or display of a particular kind of variable. So it's an array of variables. Let me show you how we create an array of variables. Let's suppose that I needed to have like 30, I could keep track of 36 different hotels. Whew, I could make 36 different variables. Oh man, this is going to take a while, even with copy and paste. Hotels 1, hotels 2, hotels 3, hotels 4. I gotta, oh man, I'd probably make a formula in Excel that actually wrote this text and I'd copy and paste it in. But if I use an array to create these variables, I can do it with one statement. Are you ready to see it? I want to create 30. In fact, let's just do it this way. I'm going to put a number inside of parentheses right after the variable name. That creates more than one variable. It creates an array of variables. How many variables have I just created? This is a trick question. How many variables have I just created? Oh, some of you got it. Say it louder. 37. So in VBA, the number I put here is the topmost index that I want to create. And it starts at 0. So if I want 35 or 36, I put here a 35. That's kind of a little bit weird. Other languages, when you're declaring an array of variables, you tell it how many you want. And then it's numbered from 0 up to 1 less than you put there. But here, it's numbered from 0 to the number that you put here. So now I have 35 different. A variable is just a named location in memory. I now got 36 of them. Here's the name for one of them. Hotels, H-O-T-E-Ls, sub 1, sub 0. Equals, what is this? It's like the Sheridan is a hotel. So the Sheridan, S-H-E-R-I-D-A-N. S-H-E-R-I-T-O-N. I don't know how to spell Sheridan. S-H-E-R-A-T-O-N. There we go. And that says, that's one. I could have another one. I could have the Hilton. Different location. Now the number 1 position here is the Hilton. And so the trick is now I have created a whole potload of variables all at once, and they are now in this structure called an array. Now, one of the interesting things about an array, when I make these variables in an array of variables in VBA, these are now actually located contiguously in memory. Like I've got a block of memory that starts here, and every one of these variables just goes one right after another. They are all right next to each other. And that's actually why it starts at 0. Is because the name, hotels, is a name for the location where this array starts. And then the number is how far I'm offsetting from that. And so the very beginning of the array is where that array starts and 0 offset from there. Okay, now what makes the array powerful is that normally when I have a variable, if I want to refer to that particular variable in my code, I have to refer to it by its whole name. I've got to write out the whole name. But now a part of the name, because this is an array, a part of the name can be an expression that comes in here. So I could have something like this. Let me dim x as an integer. X as an integer. And then I could say for x equals 0 to 35. put a next in here. And now instead of having to write, if I want to fill these up, instead of having to write that in a bunch of times, let's say I'm reading the values off of the worksheet. So instead of hard coding it, I'm going to go read it off of my worksheet here called distance. And I think that's actually named, yeah. So it has a code name of distance as well. So that'll be a little better for my code. Distance, D-I-S-T-A-N-C-E, dot cells, row number. I'm going to start on row number 2 plus X. So the first time through, it'll be 2. Second time through, it'll be 3, then 4, then 5. And I'm going to look at column 1. Dot value. So now what I can do is I can fill up that whole array by reading with that one little block of code. That loop will fill up that whole array. And yeah, it was only 36 variables, but it could be 360 or 36,000 variables that I'm all loading into memory. In fact, I'm going to go ahead and do this as a separate loop. I could do it in the same loop, but let me do it as a separate loop just so you can see it. I'm now going to do a debug.print of that. Of X, I'll do X, and then I'll show hotels sub X or sub X. Oh yeah, I better do that. I better switch to X over here. So now the first time through this loop, X is going to be 0. This is going to say hotel number 0 equals that location on the sheet. And it'll put in there Sheraton Los Angeles Downtown Hotel. Next time through the loop, we'll get to the next, X goes to 1. Hotel sub 1 is going to equal whatever 2 plus 1 is, row 3, Sheraton City Center, Salt Lake City. And it'll fill it up. And so I'm going to go ahead and put stop here to take me into break mode, and I'll run this code. So we can see that it's loaded the array and it has displayed it out here. And in fact, just for kicks, I'm going to view my locals window. And I know this is tiny for you to see, so we won't spend much time here. But if I come to hotels, we can now see that it's an array. Like I can open this up and I've got hotels 1, 2, 3, 4, 5, 6, 7, and I've got all those values right in here. So that locals window can be really handy just for looking at that. But of course, because I'm in break mode here, I can just come and say, I want to see what is hotels number 35. It's Sheraton Santa Ana Hotel. That's the name of it. So the idea behind an array of variables is that I can, with a single statement, create multiple variables. And then the magical part is I can refer to them with a combination of the name of the array of variables and the index number that identifies it. Show me how comfortable you are with what we've done so far. There's more to do here, folks. Don't worry. But how comfortable are you with what we've done so far? 0 to 5. 5, 4, 5, 4, 5, 4. Good. Okay. Let's talk about the problem that we're going to use arrays of variables to solve here. So let's suppose for just a moment that you've been hired. You've been hired by the Starwood Corporation. Starwood Corporation, they own several different hotel chains. So these are all brands of the Starwood Corporation. So Sheraton is Starwood. What's another one? Westin, you probably recognize Westin. That's a Starwood hotel. There's one called the W. It's kind of, not nearly as popular. There was a big hotel in New Orleans where I used to live called the W, and I guess there's one in Scottsdale here too. Some, are more like resorts, the Phoenician, but these are all properties. So you've been hired, by the Western Regional Division of the Starwood Corporation, and so, like no one knows you've been hired except and like your supervisor knows, and so they say, listen, you're going to start here. Let's say you're going to finish class, you're graduating in April. You're going to start in August. So between April and August, we're paying you now, but I want you to show up at the office in August. Between April and August, I've got these 36 hotels that I want you to go and study. Some of these are our best hotels. Some of these are struggling, and we might be closing them soon. So I would like you to go and just pay attention to what's going on there. And you're all, wow, like April, May, June, July, like 4 months. Yeah, we want you to be serious about this. Now, no one knows you've been hired yet, so they won't know that you're kind of there, from the company. But you're like, man, you know what? I'm married. I got a couple of kids. No problem. Take take the family with you. You know, we're going to rent you a van, and you're going to go to these, they're all over the Western United States. You're going to go to all these places. And you say, well, great. Well, you know, what order do you want me to go to these in? And your supervisor's like, I don't care. You're just going to see them all before you show up, you know, at the office. So now, if you would, describe for me the route that you would like to take. I mean, don't tell me which city to go to first. You're probably going to start in Salt Lake. That's the closest one. It's up in Salt Lake. But what route are you going to go? What's the characteristic of the route you would like to choose? You'd like to choose the route that is, why shortest? Because every minute in the van with the kids is one less minute with the masseuse, right? Because you're getting like a corporate card. You're going to eat at the restaurant. You're going to do all the services they have there and really study this place. So you'd like to figure out the shortest route. So that's what we'd like to do. We would like to have VBA calculate the shortest route for us. Is this a big issue? Like routing, figuring out like what route to go? Yes. Like who has to solve this problem thousands upon thousands and maybe even hundreds of thousands of times a day? Like give me a name of a company who has to solve this tens of thousands of times a day. Amazon. Who else? Apple. Does Apple like deliver stuff? Oh, they're like telling you where to go. Yeah, interesting. So like so Google Maps or Apple Maps, Federal Express, like this is like what they do. Now, you think about like a delivery company like Amazon or Federal Express, UPS or whatever. It's even more complicated than just what's the shortest route, because like a left turn is dramatically more expensive than a right turn, because you have to wait to turn and you're turning across traffic. Like every time you turn left, there's more of a risk of being in an accident. And so this is a really complex problem. And mathematicians make their careers working on this particular problem. This problem has a name, like in the math world. You know what it is? What's it called? Do you know? Anyone know what it is? It's called the traveling salesman problem. Yeah. And we've been working on this. Humanity has been working on this since the 1700s, since the 18th century. Like mathematicians have been like trying to find like creative solutions to this problem for hundreds of years. And there is only one known algorithm that is guaranteed to produce the shortest route. Can you guess what that algorithm is? Well, yeah, it's going to involve brute force, but describe it. What do you mean by brute force? Calculate every possible route and then do the shortest one. When I first realized this would be kind of a fun problem to teach about arrays with in this class, I thought, okay, I got this data from Starwood Corporation, just kind of swiped it off their website. And I think there was a problem, one little problem, because I think we've got one, like something that says it's in Montreal, that's address is in San Francisco. I'm not sure how that happened, but I thought there's only these, 36 hotels. I'm just going to calculate and find out what the shortest route is. And so I wrote a program to start calculating routes. And this was the early 2000s. Computer wasn't all that fast. It was pretty fast though. And I said this is going to take a little while to run. So I set it to run and I went to lunch and I came back and it was still running. And I went, oh, well, I guess just let it run the rest of the day. It wasn't my only computer. Let it run the rest of the day. And by the time it was time to go to home, it was still running. I went, oh, it'll be done tomorrow. Came in the next morning, it was still running. I went, oh, that's too long. I better figure out what's going wrong. Maybe there's some, but no, it was actually kind of crunching through the problems and take a long time. And I thought, oh man, I wonder how long it's going to take. Because it's going to take, a few days, I'd be okay. Or just, set a computer dedicated and let it run, because I'd like to figure out like what's the solution to this particular one. Because that's what we have in this table here, is we have the road distances, right? So I've got like, that is the distance between these two hotels. That's the distance between these two hotels. So I know the distance between all the hotels, just calculate all the possible routes and do it. So I did the calculations. I went something like this. I first timed how many can I do in a second? And my little computer could calculate 5,000 routes in a second. Okay, that's pretty good. Here, let's just bring up a new sheet. So, all right. So First of all, how many possible routes I'm always amazed that someone knows how to figure this answer out. Someone in this class will know this off the top of their head. How many different routes are there? How many possible routes are there? There's 36 factorial. How did you know that? You're just brilliant. You're probably brilliant. That's excellent. Okay, fortunately, there's like a formula. There's like a function in Excel that does that. It's called fact equals fact 36. I never was that good with scientific notation. So I'm just going to make that bigger and then tell it to format different. Home, format, comma. Oh. There we go. I don't think I need the decimal points on the end of that. That's how many possible routes there are. Well, rather naively, I said, all right, no problem. I can do 5,000 in a second. How many seconds is that going to take? That's a lot of seconds. Divided by 60, that's how many minutes? That's how many hours? Oh boy. That's how many days? I don't think my computer is going to do that. I don't think working with my own computer is going to do that, like ever. And at the time, it was like, you know what? I had just read an article in PC Magazine that the 1 billionth PC had been produced. And I thought, that's a pretty good surrogate for like the processing capacity of humanity. What if I put like every computer in the world working on this? I'm going to take that and divide it by 1 billion. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I got to days. I should have done years. Okay, so let's at least get this to years now. This equals this divided by 365.25. Like if we, is that a number I could even say yet? No, I don't know how to say that number. That's how many years it would take if I dedicated all of humanity's processing power to solve this. Like the only known algorithm that could solve this problem and be sure of the answer. It's like unsolvable. What's the best scientific estimate for the age of the universe? There's not always someone who knows the answer to this question. It's like 20 billion years. Okay. This divided by 20. 1, 2, 3, 4, 5, 6, 7, 9. That's a number I can say. If I dedicated all of humanity's processing power, it would take hundreds, thousands, millions, 117 billion times as long as the universe has been in existence to solve this problem. We can't solve this problem. And be sure. And so what's happened in the world of the traveling salesman problem is like, where are we like, we'd love to find a solution, but you know what? We can't find the solution. This one problem. And it's only 35 stops. How many stops do you think the UPS guy makes in a day? I don't know, but it's probably more than 35, right? What's that? Anyone ever worked delivery, like around Christmas or whatever? No? Yeah? About how many deliveries did you make in a day? Okay, yeah. So this is 36, and solving this problem like it's impossible. How do you solve it if you're doing 300 on each route that Amazon has to do? It's crazy. So mathematicians are like, you know what? We got to figure out how to throw away big parts of this problem without having to actually calculate all the possible ones. And say, you know what? We're 99% sure that that chunk we just threw out doesn't really have the best answer in it. So like there's like really kind of heavy lifting in the world of mathematics to kind of come up with good solutions, even though we know we can't get the guaranteed best route. So what we're going to do, so we're not going to try to get the best route. We just don't have time by the end of class. We can't do it by the end of class, as you can tell. So our task is going to be to calculate a particular algorithm, a known algorithm that is called the next nearest city algorithm. So what we're going to say is we're going to say start somewhere and then ask yourself, who's closest to here? And then you'll go there. And then you'll say, who's closest to here? And by the way, you can't go back to where you just were. So who's closest to here that we haven't been to? Go there. And then we'll say, who's closest to here that we haven't been to, go there. That algorithm is virtually guaranteed not to give us the shortest route, but it will give us a route, and we can calculate it in less than a second. So that's going to be our task. And along the way, like, we're not really trying to solve the traveling salesman problem. We're trying to learn about arrays. And so we're going to learn a little bit about arrays. So should we do it? Let's do it. Okay, so let's go ahead and we're going to start off by declaring the arrays that we need to solve this problem. Now, on our worksheet, we've got a tab called arrays. And this one here is just to kind of show us the arrays, like a visual representation of the arrays of variables that we're going to build. And we've already done the first one. It's right here. It's called hotel. Actually, I called it hotels. Just maybe call it hotels here. It's called hotels, and it's going to have how many? Just highlight that. It tells me I've got 36 things selected down here, and they are numbered 0 through 35. So I should be able to see that over here when I printed off those hotels. Yeah, here they are. And they're the same ones. 0, Sheraton, Los Angeles, Sheraton City Center, Phoenix, Scottsdale. Those are the same ones right here. Those are like the same ones. So this is just on a spreadsheet, a visual representation of the array of variables that I've already implemented in my example. The important thing to realize here is that the array is not the collection of cells. What we're seeing on this sheet is just a visual representation of what we've done in memory. Show me how comfortable you are with what I've set up so far. 0 to 5, 5, 5, 5, 5. Okay. So now what we're going to need to do is we're going to need to get an array. This is a little different because this one is it's not just one set of indices, it's 2 sets of indices that we use to identify the elements. This one's a little more complicated to set up. But this is going to be an array that holds all of the distances between our cities. So like the original distance problem is here. These are on the sheet. We're going to read them off of this sheet and put them into an array that looks like this. And you'll see that these numbers are just, in fact, do I have these as decimal points over here, or are they, oh no, they're integers here as well. Okay. So why is it that this one is like all full except the diagonal, and this one only has them on part of it? What's the difference? Why don't I have any numbers down here? Like, how come that has a 691 and that doesn't have anything in it? Say it again. Well, it's not because they've been visited, because this is just showing what are the road distances. Like that says it's 26 miles between the Sheraton Los Angeles downtown hotel and the Westin in Long Beach. It's 26. That's the road distance between those two. Yeah.
Because C2 is connected to the same hotels as B3.
Exactly right. Yeah. So there's no new information down here. Sometimes when you'll see tables like this, like printed on the bottom of a map, maybe you're touring in Europe and it's got, like here's distances between the main cities in Europe. It'll show miles for we Americans on one part of the diagonal, and it'll show kilometers on the bottom because it's the same information. It's how far is it between those two cities. But in this case, everything is in miles. And so there's just no information, no reason to have information down there. And yet it'll be a little bit simpler for us to solve our problem if we fully specify that array over here in the array, because now we can look at either one column or one row, and that will give us the distances between the number 5 hotel and every other hotel. So this will simplify our problem a little bit if we kind of fully specify this, because now we can say, hey, who's closest to number 5? Well, all the distances for number 5 are right on that one row. I don't have to think about anything else in the array but that one row. So we've got our hotels array created, and then this one, and so this is what we're going to use to solve the problem. These will be the names that, like when we print it out, we'll want to be able to see the names of the hotels that we're going to. And then the route is going to be like this is the route that we're going to calculate. In fact, we're going to start off by saying go to Salt Lake. Salt Lake is the number 1 hotel. 0 is the starting hotel. The number 1 hotel is Salt Lake. And we're going to say start in Salt Lake. So we'll say, we're going to go to number 1 first. And then we're going to go, what's next? It turns out number 7 is next. The closest one, I've solved this problem several times now, but the closest one next is Las Vegas. So ultimately we're going to put a 7 in there. And then after that, I don't remember what's next. After that will be another one. And we'll just put the index number of the hotel that we're going to, and that's how we'll fill that up. So let's go ahead. We've created the hotels array. Let's create the route array. So what can you tell me about the route array? Tell me something about this array that we have to build. You could say maybe the size of the array, the data type of the array, or something. Go ahead. Okay, so yeah, we're not going to want to have duplicates. So we'll have to do something to know that we've already been to it. We're going to do that. But just in terms of declaring the array, what are the characteristics of the array that we're going to declare? And specifically, how big is it going to be and what's the data type we should use for this? I'll give you the name. It's going to be called route. How many variables do we need in the array? There should be 36 integers because we have to put an index for every hotel. Everyone's got to show up in the route. So we need 36. There's 36 hotels. We'll need 36 in the route, and we just need the integer. We don't have to put the name in here. Just the number will be fine. And so let's go ahead and declare that. So I've declared hotels 35 as string. Let me declare route 35 as integer. Now, I could get by with byte for this particular problem because that'll go 0 to 255. Can I imagine wanting to solve a problem larger than 255 stops? I can imagine that. I can even imagine wanting to go larger than 32,000. So why don't we go ahead and do that as long? I'm going to do this one as long. It's not that much more memory. I'll go ahead and do long. But this is one of the reasons that we do want to think about using the right kind of memory, because when you're declaring an array with one line, you could create thousands and thousands of variables. And so how much memory using could make a difference. Okay. Now, when I declare my hotels array, every data type has a default value. What's the default value for the string data type? Empty string. Now, when I declare a route, all numbers have a default value too. What's the default value? It's 0, right? So let me go ahead and get this started off with what's actually going to be in here. So 0, 0, I'll just copy that down. So I'm just going to put that in there because that's what that's going to start off with. It's not, numbers are never blank. Numbers are always a number. A string can be blank, it can be an empty string, but number always has to be a number. By the way, what's the problem with this array right now? You suggested that we're going to need to ask, have we been to a hotel yet? And so if I start off and ask, have I been to a hotel? What is this array telling me? What hotel have I been to? What's the name of the hotel I've been to? Yeah, this Sheraton in Los Angeles. It happens that the default is that this is saying, hey, you've been to hotel number 0 a bunch of times already. That's going to be a problem because we have to say, we're trying to figure out where we're going. Don't consider any place we've already been. And we've already been to hotel number 0. So let's do this. Let's go ahead and say, when we're starting this off, we're going through these 35. Let's just go ahead and put a value that's outside of range for route. So I'm going to initialize route. So route sub x, first time through route sub 0 will get a value, then route sub 1 will get a value, route sub 2 will get a value. What number should we put there? $42? 42 would work. Why does 42 work? Yep, that's not one of the hotels we've been to. Why do I dislike 42? Someone tell me why 42, although it would work for this problem, tell me why it's a bad idea. Thank you for saying it. It's not a problem, but that's right. If I go above hotel 42, all of a sudden I'm going to get more. And I've set this up to be able to go to like 1 billion hotels, right? Because I've said my route could be long. So other thoughts? Can't take 0.5 because I put 0.5 in, it's going to convert it. Go ahead.
Find the last hotel on the list.
Oh, that would be good. That's one approach. We could start off by saying, let's just go find whatever that number is, and we'll plug that one in. Like, go find out what my last one will be, and then that'll be it. Ugh. fact, I know that here. I'm gonna have to make this dynamic too at some point. That seems like a lot of work. Yeah, we could do it. There's a much simpler approach. What's something that's outside of the range that I'm never gonna bump into? -1, beautiful. Yeah, I'll just close with it because it can take a negative number, and my arrays are going to start at 0. They're never going to have a negative index. Arrays do not. There might be a way to make an array take a negative index, but by default, the way we're using them, they're not going to ever have a negative index. So that will initialize this to -1. Let me just go ahead and run this code again, and I should be able to kind of peek at route now, anywhere, route number 3, and it should be -1. Everywhere I look in my route, it should be -1. So good. So we've initialized this to -1. So I'm just going to kind of put that in as starting at -1. Okay, so we've got the hotel array built. We've got the route array built. Now we got to do this distance one. But I think before we dive into distance, let's make these, I'm going to do 2 other things to what I've declared so far. The first thing I'm going to do is I'm going to change the scope of these. So right now, these are declared inside of my subprocedure. That means the only place I have access to these variables is from code that is also inside this subprocedure. So by just dragging this outside of the subprocedure, I have made those into module level variables instead of local variables or procedure level variables. And so now if I have 2 different subprocedures, they can both look at those same, in fact, any subprocedure inside this module now can look at those variables. And that's good because I've got this subprocedure that's just putting my initial values in, and then I'm going to have some other ones that need to like actually do the calculations to like figure out how we're going to put this route together. Now, the next thing I'd like to do with these is I would like to say, listen, I don't know that it's going to be 35. Right now, everything's hard-coded to 35. I'd like to figure out what the size is going to be. The temptation, and I'm going to bring this back down into the executable code for just a second to kind of show you the temptation. The temptation is to say, let's figure out the number of hotels. I'll just do that right here. Dim number of hotels. I'll call it hotel count as a long integer. And now let me just go ahead and fill that in. Hotel count, H-O-T-E-L, count equals, and you know what I'm going to do? I'm just going to assume that the structure of my distance sheet is going to be unchanged. So I'm going to start there, and I'm going to say, you know what? I'm just going to start in A2 and just do like a control down to find out where that ends. So I've got my distance sheet dot range A2 dot end XL down dot cell. I'm sorry, dot row. That'll give me 37. And what I'm looking for is my hotel count. So I'll subtract 1 off of that. I'm going to run to this point right here, and I'll see what my hotel count is. My hotel count is 1. What's the problem? What did I do wrong? Hotel count equals, oh, not range A1, it's A2. There we go. Okay, so 36. So now I've calculated the 36, and I just want to subtract 1 off it. So the temptation here is to say, oh, great. Now all I have to do is come in here and say, hotels is going to be dim hotel count minus 1. That'll get me 35. The problem is my dim statement is executed before the code starts running. So the way this happens is when I'm saying, hey, I'm going to run this subprocedure, that subprocedure gets loaded into memory. The code gets loaded into memory. But before that, the interpreter looks through and says, what are all the dim statements in here? I got to allocate that memory. So it gets allocated before the code starts running. So the thing is, even though this happens above it, even though this happens here to figure out what the hotel count is, this line actually gets processed before that because all of my dims happen straight away. That's the reason that you cannot put a breakpoint on a dim statement, is because you can't stop there, because they all get processed before the code starts running. Pity. So here's what I'm going to do instead. Instead, I'm going to declare this without telling it how many to make. And since this happens before, I'm going to put it up here. Ultimately, we're going to move it up to make it a module level, but let's just do it right here for now. So this says, hey, I'm going to make an array of variables. You call it hotel. And the interpreter's like, great, how many variables do you want? And I'm like, I will tell you how many variables I want when I am good and ready. You just get ready. That's what we're saying. This is called a dynamic array. I can change the size of this array once the code starts executing. And I do that with the redim statement. So redim is executable. I tell it what array I want to redim. And then I put, the size I want to make it. And because this is executable code, now I can redim it to that size. So I will redim hotel, I will redim route to be that size. And I will also change my loop to execute up to that hotel count -1. Ooh. Interesting thing about redim. When you say redim, remember that an array, the array has to have all of its variables lined up one right after another, sequentially in memory. And so when you redim, like, hey, you're going to make this thing bigger? There might not be room over here to just extend it. And so when you redim, it actually says, oh, we're building this array again from scratch. It's got a new size. We'll go find somewhere in memory that we can put the whole thing in memory. So when you redim, it's not like we're making it a little bit bigger. It's like we're making a brand new array that's that size. Now, after you make that new array, if you want to copy the old values into it, like when you redim it, you're saying, hey, the values that were in here before I started to redim it, copy them over. You can put the keyword here, preserve. So redim preserve says, after you make the new array, copy the values from the old array into the new array. It is not an efficient process. Sometimes I'll see code like written like on help sites for VBA, and it's like, oh yeah, you're not quite sure how big it needs to be. Just redim it every time you need to add a new thing to it. It's extraordinarily inefficient because if you got a big array and you redim it to be one bigger and tell it to preserve, it's going to like, okay, great, copy the whole array somewhere else, or make a new array, copy all the values in, and then move on. So we don't need to preserve because we're not changing anything here, but I'm just letting you know that's what that syntax is. Okay, there's a question here.
Oh, I was just wondering if the hotel was supposed to be hotels or
The hotel is supposed to be hotels. Thank you. Yep. Okay, so now I am going to go ahead and move these up to the top so that they will have module level scope instead of local scope. We're declaring this, we're reading the size, we're redimming. That should now still work. I'm going to go ahead and run the code at this point and see where we are. Yeah, so it still runs just fine. My route, I should still be able to look in route. Sub4, got the -1 in it. So everything's working fine. But now these are dynamic arrays that we are setting their size after the code starts running. So if we were to just like add a few more hotels in here and we had more, like we had like the rest of the information about how those are located, how far they are apart from each other, it would solve whatever problem we throw at it now. Once it actually starts, at least to load the arrays at this point. Okay, We have one more array to build. Let's call it dist. I can't call it distance because that's the name of this sheet. So I'm going to call this one dist. It's also going to be a dynamic array, dim dist, as, what data type should we use for this one? They're integers. I've got some that are larger than 256. Am I expecting to see anything more than 32,000? What would it mean if it's 32,000 miles between hotels? Well, it's road distance, so it could be. But like the circumference of the Earth at the equator is only 24,000 miles. Like if you've got two hotels that are 36,000 miles apart or 32,000 miles apart, that's a crazy route to get there. So you know what? I'm going to go ahead and do this one as integer. And dist needs to be an array, dynamic array, so opening and closing parentheses. Okay. So now when I redim, okay, I'm going to also now redim dist. I can scroll up till we can see all of that. Whew. But if I just redimmed it to hotel count, let me go ahead and do the hard coded first, then I'll put in the variables. So 35, hotel count minus 1 is 35. But now I'm going to say, you know what? This is going to be a two-dimensional array. So now our array is like pigeonholes or post office boxes. It's now, or we can think of it as a grid. So now when I refer to one of the elements in the array, I have to give it both indices. So which is first? Is it row first or column first? And the answer is, it doesn't matter. It's just a metaphor. You just have to be consistent. You could think of it as row first, column first, or row first. Sorry, you can think of it as row and then column. You can think of it as column then row. And as long as you're consistent, it doesn't matter because you know what? It's not really a grid. It's still just one long contiguous set here. And the indices we're going to use just to refer to the same one. So when I say 2, 1, that's always going to refer to the same one of those, the same variable in that memory. I don't have to think of it as a grid. I could think of it as buckets. I now have 36 buckets lined, or 35 buckets lined up here in front. And what's inside of every bucket? 36 other buckets. And so the first number just tells me which big bucket to choose. Ah, there's the one. And then when I want to get the value that's in, like the actual value, now I look at the second number and say, which bucket is inside there? Oh, it's that one right in there. So it's all just a metaphor for how it doesn't matter. The simplest way is to think of it the way you're used to working with a spreadsheet. Row first, then column. And as long as you always think about it that way, you're excellent. So I'm going to put here, like I'm just going to like put a single value in here. Dist, row number 0, column number 0, 1, 2. I'm going to put, I'll do this one. That's row number 0, 1, column number 0, 1, 2. So row 1, column 2, dist, row 1, column 2 equals 653. Is that right? Row number 0, 1, column number 0, 1, 2. Yeah. And so that's, I got to do that a potload of times to get those values in there. As you might guess, I'm going to be doing that with a loop. I'll be reading it off the sheet and writing it up to the sheet. So, and so once I do that, I can then call that back. I can print that just by specifying the same thing. And so now I've identified one of those variables, and it's going to have 653 in it. When I ask for that same combination of indices, it'll identify that particular variable. Okay. So tell me how comfortable you are with the idea of a two-dimensional array, 0 to 5. 5, 5, 5, 5, 3, 5, 4, 2. Okay. Well, it is 2 dimensions, so being a 2 is probably okay here. So the thing to realize is that I'm kind of, let me make this a little bit smaller for right now. Let me make this just like 3 and 7 for just this little example. So when I'm assigning these now, in my first dimension, my valid values are like 0 is a valid value for that first one, 1 is a valid value, 2 is a valid value, and 3 is a valid value. And then over here, I get a valid value of 0. Where'd my 0 go? 0, 0, 0, and 0. So I've done 4 of my variables right there. I could then do, the next set of 4 would be like this. 1, 1, 1, 1. The next set of 4 would be 2, 2, 2, 2. And I could keep going with that pattern up until I got to 7. And that would have fully specified all of those. Like I've got every possible combination of indices that are legal, because my first one is allowed to go from 0 to 3. My next one is allowed to go from 0 to 7. And then I will have filled out every single variable. So the idea here, I've got these indices and every possible combination of indexes to put in there is going to refer to one of the variables in the array. Question? This is as far as we're going for this example, but could I declare an array with 3 dimensions? Yeah, I could think of it as a cube. Could I do one as 4 dimensions? Yeah, I can't think of that one. But you can, because right, all it is every possible combination of indices that are in the ranges specified here. So that's how I would get to those different variables. I was solving a problem one time, I was really struggling with it. I was like, oh, there's gotta be a better way to do this. And I realized I need a 6-dimension array. Like one time in my programming life, have I ever made an array that was larger than 3 dimensions? And it was like, I needed a 6-dimension array, it solved the problem. And I was like, oh, that was delightful. But yeah, because it's hard for us to think, past that space. Okay. So I'm going to take this back down now, and let's declare it as the size that we need. So it's square. So so both of my indices will be the same. So 35, 35, which will give me 36 rows, 36 columns. And now I'll work on a loop to get things filled up. All right, don't need to print that. Dim x as an integer. All right, let's do this. I'm going to come in here and let me dim y as an integer as well. Dim y as an integer. And we're not going to use this straight away. But what I'd like to do is I would like to read my first, I'd like to kind of fill in this first row in my distance, in my dist array. So here, I'm already taking this from 0 to 35. I'm initializing my hotel, I'm initializing my route. Let me just go ahead here and initialize that first row of my dist array. So dist, and we'll do row number 0, column number x. Is going to equal, and then we'll offset from this sheet as well. And so that is going to be distance cells row number 2 plus x. That'll get me onto this. No, it's going to be row number 2, column number 2 plus x. Is that right? So when x is 0, the column I'll be looking at is 2. 1, 2. Yeah, I'm going to put that in my 0, 0 position. So when X is 0, this will be 0, 0, and that will be referring to that cell right there. The next cell will bring in, as I go to X sub 1 or 0, comma 1, I'll be putting a value into that part of the array, reading from that cell. Yeah, so that should fill those up. I'm going to go ahead and put a stop right here, and I'll run my code to that point. EIST, and I'm going to look at row number 0, column number 0. So the very first one. What should I expect to be in my array at that point? Yeah, it has to be a number because my variables are numbers. And I think I actually did try to tell it blank in there. And when you try to assign a blank to a number, it goes, oh, you silly programmer. You can't put blank in a number, but blank is kind of like 0. I'll put in a 0. So that should give us a 0. I'm still on row number 0, looking at column number 1 should give me that 691. And column 2 should give me that next number over. Yeah. Column 35 should give me whatever is at the very end over here. 1139, 1139. But if I look on row number 1, I don't have anything because this loop only took me, this loop only ever wrote to the 0th row. I want this to happen over and over and over again, 35 times. So that's what I'm going to use that y variable for. Y equals, and we'll just do this. We'll start off, we're going to change it, but let's start off with the same thing. 0 to the hotel count. Next. So the first time through, y is going to be 0. So I'll just put the y here. That's fine. And now I'm reading off the 2 plus y cell. So that's when y is 0, I'll be coming across the second row. When y is 1, I'll be doing the next one, and so forth. I think that's going to read that whole array, that whole range into my array. You see what we did? So here, this was filling up every column on that first row. And now we've said, just do that process 35 or 36 times as we go through this, changing where I'm writing to and changing where I'm reading from. Distance 0, 0, 1. And let me just see what value it says. It doesn't like the type. It's like I'm trying to put a string in to a number or something. And it looks like it's either a space or a blank. What is y? Y is 1. X is 1. So it was when I got to that next. What am I missing, folks? Let me print off these two values. These should both be, this should be 3, 3. So I'm trying to read from row 3, column 3. And is there a space in that cell? Blank should be just fine. Did anyone try that and not get the error? You got the same thing that I got. Okay. So let's see what this is. Can't see it, so let me ask for the length of it. Zero, let's ask for the type. String. Okay. That's a 0 length string. I'm not quite sure why it's not taking that. I think it should assign that into 0, but it's okay. We don't really want to look at the whole thing anyway. There's no reason for us to read that cell or read these cells. So let's have it when my X, I'm going to think of these as the 0 indices here. So when my X is 0, I'm on the 0th row, where should Y start? I'm only looking at the numbers. Y should start at 1. When X is 1, Y should start at 0, 1, 2. When X is 3, Y should start at, or I'm sorry, when X is 2, Y should start at 3. Yeah, it's always starting one more. So instead of starting this off at 0, I'm going to start this off at x plus 1. So when x is 0, this will evaluate to 1. So it's coming through, doing that x line. It's now only reading in the data that we have here. Okay, so let me go ahead and run that. I'm not quite sure why that failed, and hopefully this won't fail. Y is 2, x is 1, 0, 1, 2. Let's see, x is 1. All right, I got to see what I've done wrong here. And I've done this a little bit different than I have in the past, but this seems like it should work to me. So we've got just a minute to go. Let's call it good from there. We'll pick this example up here the next time we get together, and we'll get this array populated, and then we'll be off and running. Thanks for coming. Class dismissed. Hey, you bet.
See you at the office.
Okay. Looks like I just needed to change the order of these, the X and the Y here. And now that looks like it's going through okay. So if I look at distance, where the row is 1 and the column is 2, the row is 2, column is 1.
You guys gotta let us know when you're free though. We're super done. I don't think